All right, it's 3 o'clock. Thank you very much for joining me today. Hey, and the last time went so well with the 4 exercises that we solved on Excersim.io, so I want to go further with it. And as you know, I don't rest if I'm not finished all of them. And today I want to go with the prime factors and maybe the diamond, and I will work like round about 1 hour to solve some of these issues. So without further ado, I think we should start, right? So let's go into the prime factors. And if you don't was there in the last time, so what Excersim is it allows you to write some exercises. And the benefit is that you have the your own environment, so you can download it or clone it on your device, and then you can open it as every project that you have in Dart. And how you do it is with a test-driven development system. So you have a test, you make it green, go back to the code, solve the issue, go back to the tests, solve the issue, and so on and so forth. But I will show you that. So first of all, we should always read the introduction. And after that, you see here on the right side, there is a download terminal enter that you can do, and also a submit one. So if you are finished, you can submit the whole thing. But okay, so let's read it. Compute the prime factors of given natural numbers. A prime number is only evenly divisible by itself and 1. Note that 1 is not a prime number. Okay. What are the prime factors of 60? Our first divisor is 2.2 goes into 60, leaving 30. 2 goes into 30, leaving 15. 2 doesn't go cleanly into 15, so let's move on to the next divisor, 3. And so on and so forth. Okay, we are left only with 1, so now we are done. Our successful divisor in that computation represents the list of prime factors of 60, 2, 2, and 3 and 5. You can check this yourself. 2 times 2 times 3 times 5, 4 times 15, 60 success. All right, so sounds very complicated, but at the end, I think everyone knows prime factors, and if not, you should really read about them. They are very important. And as you can see, you have also the source where this kata comes from. And what a kata is, it is a very short training session that you always can do to improve your development skills. So in that case, it is one from Uncle Bob, and he is a very good C# developer and very famous for his clean code book that I can really recommend you. But now we want to copy this terminal code here, and if I open up a terminal, oh, I see you can't see it correctly. I'm sorry for that. I make my picture smaller. So, and let's see. So I copied the download one, and if we go into the terminal, we can just copy that code inside. And now you can see we get a file or a folder from prime factors inside of Excersim. And with that, I can open up Visual Studio Code and I can open up that project. So let's go into Dart, where we have the one, and we search for the prime factors. Let's open that up. And here we see always the clean folder structure. And first of all, we have to get the packages of Dart. So we do that. And the only packages that an Excersim task has is usually the test one and the SDK. So there's nothing else to it. So now we let run the test. Everything is get. And what we can do next in our nice little project is we can just run pub run test. And as you see, there comes a lot of errors with it. The problem with that is that in our test here, usually these tests initialize the class or an instance of that class, prime factors, which we have in the library. And the library is just a class at the moment with without any code. But our tests want to have at least one function inside, which is called factors. And it delivers us one number. So if we take that factors, we should write that function here. So let's do that. First of all, we have to identify what we have to return. And it seems that our test expects that we return a list of integers. And so we can write that in our method. We want to return a list, or better we can do it like list of integers, and call it factors, which receives one integer, which is the prime factor most likely, or test factor maybe. And if we run that, we want to return for now null, just to see if our tests are getting a bit greener, so that we get rid of these very brutal errors that we have here. So I run again pub run test, and as you see, we have 0 successful tests, we have 6 ones that are skipped, and 1 test that is failed. And if we go back to our test, you can see the first one has skipped false, and the second one true, true, and so forth, and so on. Good. So the first test expects that we just return an empty list. And so to fix that, we could just return an empty list for now, just to make the smallest viable thing to do. So with that, we fixed already the first test. But of course, this is not the solution that we want. What we want is that the factor of 1 is not really a prime factor. But we will come to that later, as soon as we are on that part where we have to fix it necessarily. So now we give the second test, and this is the factors of 2. So we let the test run, and we get another failing test. Very good, because we return an empty list, but what we actually should return is 2 in the list. And now we have to fix both tests without breaking one of them. Okay, so what we want to do is, if we have a 1, then we don't want to, or if we have only one number and the number is 1, then we want to return an empty list. But if we have a number 2, which is a prime factor, so we then have to return 2 in a list. Okay, so let's think about that. The easiest way would be that we try to return this one and get at least the second test now green. But now we have the first one that is failing, right? And with that we can say if test factor, which is an int, is divisible by 2, we return this. Oops. Is divisible by 2. No, wait. So let's read first what we have to solve actually. That makes more sense, I think. So our first divisor is 2. 2 goes into 60, leaving 30. That has nothing to do with that, I think. So, but to solve that test, let me think. We have a 1 that should return an empty list. Okay, so easy enough. I can just say if test factor equals 1, then we run to return just an empty list. And else we want to return 2. And with that, the tests are green, and we're going to the next test. And here is getting different, because now we have the prime factors of 9, which is 3 times 3. So pub run test. So, and with that, our 2 is not working anymore in standard behavior, because now we have to calculate if it is divisible by itself or 1. So let's see. Let's read once more here the example. So how can we solve that? So we have our first divisor is 2. 2 goes into 60, leaving 30. 2 goes into 30, leaving 15. 2 doesn't go cleanly into 15. So let's move on to the next divisor, 3. Okay, so 2 times 2 times 3 times 5, 4 times 15, 60 success. Okay, so 2 times 2, how can I see that? So our first divisor is 2. 2 goes into 60. Okay, is that possible with our number? We have 9. So 9 is not divisible by 2, it is divisible by 3. So that means that we have to try to divide by anything but 1. So what do we get? We can say that the test factor modulo, can we do it with a modulo? I think so. If the test factor is modulo from 2, should be 0. And then we have to return a list with a 2 inside, right? So what we can do is we have to create a result list that I would leave empty for now, but it is a list of integer. And in this result list, we want now to collect all the possible results here. So I'm not sure how I will do that for now, but if the test factor is modulo 2, we have to return a 2 inside of that list. So result list dot add, and now we have to add a 2, because that would happen with the 2, right? And if we now return that result list, we have add 2, but we don't return that, of course. We just add it there. Let's see what happens. The free is still failing, but the other tests are still green. That is good. So now what we have to do is the test factor modulo free. And now I'm seeing a pattern here, because it seems that we have here always n plus 1, right? So n is a number, plus 1 is the modulo that we always have to use. And if I see here now result list dot add is free, or also in that case it would be n plus 1, right? So let's see, we will let that run. But we get now only once free. So, but what happens here? We divide it by free. I think I have to read once more exactly what the prime numbers, prime factors are. So let's Google for prime factors. Let's see what happens here. So geeks for geeks, sound good? Is a factor of the given number which is a prime number. Factors are the number you multiply together to get another number. In simple words, prime factor is finding which prime numbers multiply together to make the original number. The prime factors are 15, are 3 and 5, because 3 and 5 equals 15, and 3 and 5 are prime numbers. Okay, so what do we have actually to do here? That means there are only one unique prime numbers, I know that, so that is write a function to print. Okay, here we come to the solution. That is not what I want. Okay, so it seems that we have to divide by 2, for example, and get a new number, which we have then to divide by another number. And because it's a 6, it is divisible by 3. This one is divisible by 2 first, 3. 91 is divisible by 1 and 7. Is that right? Yep. 7 times 9, right? How it comes to 7 times 13? Interesting. Circle the primes as they appear. And what is the solution here? 2, 3, 2, 7, 13. Okay, so we get one number divided by 2 if possible. Okay, that is really interesting. It's a cool topic. Let's see. So we divide our by 2, and if this is possible, we have to add 2 to our list, right? And we have to do it as often as possible for n plus 1. Not necessarily n plus 1, right? Could be any number. But if it is not divisible by 2, then we have... But when does it stop? If we reach itself, or... So that means if the test factor is our finish line, right? So we have to transform it all the time. Interesting. So how can we do that? We get a test factor that could be, in that case, anything like 1092. So now we search the first number that we can divide it through, so 2, 3 or something, till we can't divide it anymore. and we have to save the new result somewhere that we can go further with it. So it seems we have to divide it till, so while we can divide, don't know how, that is now pseudocode, so as long as we can divide through itself, through less than itself, and after that we divide it, and then we have to get the number that is left, right? So let's see, we have to divide that number by 2. So if test factor, let me think. How can we write that while, or as long as something happens? So as long as we can divide through less than itself, the test factor is now 9 in our case. So we divide by 9. Can divide by itself. And then test factor. So that needs to be returning true or false. Is it possible to divide by itself? Let me check. We take that and write an own method for it for now. So we get a number, and we have to check if we can divide through anything. So if number is divisible by, what is it actually? What is the algorithm that we need here? We have in order to make the property naive, so we're given a number n, write a function to print all prime numbers n. If the input number is 12, then output should be 2, 2, 3. And if the input number 3, 1, 5, then output number should be 3, 3, 5, 7. While n is divisible by 2, print 2 and divide n by 2. Okay, so while n would be test factor is divisible by 2, 0, we have to add to our result list dot add, we have to add 2, right? But it will be infinity because, well, if it is once true, it will stay true. I think that is not the only thing. After step 1, n must be odd. Now start a loop from while n is divisible by 2, print 2 and divide n by 2. Okay, so we have also to divide it here inside. By 2, for example. So what we have to do is we do this, if this is possible. Up. Test factor is the number that we get here, which is an integer. And if this number is divisible by 2, then we return a new number. No, should we divide it already here, or can it only be divisible by 2? So if we divide this number by 2, what would happen? So if this is possible, we divide the number by 2. Divide is 2. If divisible, add 2 and the answer to your list. Yes, but we still have to think how it goes further. So for example, with 9, we would make if 9 is divisible by 2, and then we have to go with the new result, which is still 9, and say it is divisible by 3, and divide it by 3, add it to the result list, and bring it back into it. Or so that would not necessarily help. So we have to make number at the end always number plus 1. So let's see, we have that number that we divide now by 2 and we return that integer wherever we use it. Why is it red? It's a double in that case. We have an integer and divide it by 2. He thinks it can be a double in that case, but yeah, let's have a number here, but I'm pretty sure it is not possible. Or else we return the number, right? If it's not divisible by 2, on the other hand, we could also say if it is then divisible by 3, 0. But this would be infinity long, right? It could be anything that we could have here. So we have a number and we should have also a number to divide it against. Number to divide. And I have an idea. So if this is the number to divide and we have a number, we can get rid of this in that case, because we return then always the number divided by number to divide. So, and else we return the number itself. And we get rid of this because the method is now done. So that would say that if we... Oh, really? That works? I didn't know that. So if I add something like that, it knows now that it is an integer? Ooh, cool. All right. Thank you. So what does it say? If either operand is a double, then result truncated division A is equivalent to truncate to int. Okay, that is interesting. Cool, so divide by n by number. So let's see, by number to divide. And the thing is, we need now a loop that is running not while, we have to need another loop. And what we need is, we have to divide it, and this one number, so if we call this number with the test factor, and for example 2, then it will run here inside and we'll find the number to divide as 2, and the number is the test divider. And the number will be returned, right? So if there is no number that is divisible by 2, then we return that. But this 2 has to increase, and the most important thing is that that number has to increase till we reach the new value of test factor. So what we need is an integer value, I think, that we call null for now. And what we also need is for loop, because we have an integer that is 0, and e is smaller than this value. And else we say e++, and this value is at the beginning test factor. So we need a value that we can have in the meantime to store a value in between. Okay, so now we have a for loop that iterates e. So we check now every element between, and we know exactly that if it's 1, then we are anyway done, right? So that we can say, so if the test factor equals to 1, then we are finished, then we don't have to start even. So I would say if test factor equals 1, we return an empty list. Because then we don't have to start, right? According to our tests. So, but this will not help us, right? Because this just returns a new number. And additionally, there's 2 here has to change to e, because that e is the new number that we want to divide by. But the problem is we have to reset that all the time when we get a new value, right? Right, so why do we make here a for loop? I think what would be much better would be a while. We say while this is working, we don't set this value because we have to change that multiple times. So we have our value, that is the one that we're coming with, and then we divide by the number, and we have to set I back to 1 if we get a number. Is that right? So if we have here a new divided number, and if divided number is equal to the or to the value, then what? So if it is the same number, then I would say we have to increase I. And we have to set the value int I equals 0. So that means if the number stays the same, we have to increase the I. But if this is not the same, then we have to reset I to 1. Because still, if we to 1 or to 2, because 1 is anyway done, right? So I think to 2, and I has to start with 2. So, and if this is happening, the divided number is here inside. And what we have to do else is, if we increase it, we don't have to change the value. But if we set it back to the value, we have to say here value equals the divided number. So what do we have to do with our result list? Where can we add something? I think we have to save I in the meantime, right? So if we are in that loop, we are running through it, we save the divided number. And whenever the divided number is not the same like the number that we are in, then we have to add it here, right? So I would also say the result list add the value, the divided number, or no, E, I think. Because E is 0, no, it starts with 2, I think, exactly. So if 2 is here, and the number is also 2, yeah, then we go inside, we have a divided number, it divides by 2, so we get back a 1, and the number E is 2. And 1 is not a prime factor, and with that we could also already solve the issue, I think. Let's see what the test's telling us. Takes pretty long, so I think I created an infinity loop. So where it is, the while loop seems to be infinity because I is not getting increased now. So we're coming into the else part, we divide it, we set the new value into it, and if I is smaller than the value, how can it be? If I is smaller than the value, yes, exactly. And value is divided, so it is 1. So let's see what we get if I print I in the else part here. Yep, all right, so it is exactly what I said. Cool. So we managed to get an infinity loop because that is still running. So and I is printed here. We set it back to 2, which always is smaller than value, even though we set the value to the divided number. What is divided number actually? I think I should make something like that just to, or leave it for now and just print the divided number just to see what we get back. Wow, stop. Okay, the divided number jumps between 3 and 9. So that means the value is 3 or 9 and I is not getting increased. So because divided number is never the same like value. Okay, I think my exit part is not correct yet. So I remove that for now. But we are coming closer. The idea is not bad, I think. We have the result list on the first test, that is true, but here we create an infinity loop. We're coming in, we would divide our numbers. So for example, we have 9 and we divide it by 3, right? So we're getting back a 3, we are coming here. And because 3 is of course not the same number as 9, we are jumping here. So we set our I to 2 back, because 3 has to be checked against 2 and 3, right? Then we have 3 here. The value gets set to 3. Okay? But we don't change that number. So that is the problem. So if we are coming back with a 3 that is not divisible by 2, we're coming back with a 3, which is still not the same, and so on and so forth. So this is not how it works. Okay. Divided by number to divide. So let's see, what do we have? That's a bit utter. That is a class, so we can use it here inside, of course. And also remove here some parts. Did I make a mistake? There is a missing, voila, another one missing. Okay, cool. Now it's getting cleaned up. Okay, divided by number to divide. What? This is the while loop, so this needs to be outside in the method and inside of its own. Cool. So, but still, we have the number, we divide it by another number. And this needs to be, for example, 1, 2, or 3. And if the number modulo number to divide is 0, then it's possible to divide it. So, for example, 9 divided by 3 is 2. This number, is that correct? By 3 is 0 because it's 2, right? And this one returns us then 9 divided by 3, or? Good question, I don't know, I have to check. And what is here wrong? Okay, it has a return type, but doesn't return always. Okay, but slowly. Maybe this here is a bit too much yet. So let's see, what do we get in the print divided number? And to finish off the while loop, I just make here a plus plus for now, just to see what we get. Okay, so we can see the first test is passing because we just jump out of it, right? That is this part here that is working fine. But the while loop gives us a lot of feedback, especially for the 9, we get here interesting prints. So we get here into the divided numbers, we print once 9, then 3. While, okay. I always give inside the test factor. That is the problem. Of course, the value needs to go inside here because we want to change that value, of course, over time. So value equals divided number. And that could already help us with our method here. Aha, here we go. So that could lead to the issue that we had. So if I'm starting and bringing back my stuff that I had before with that if statement, and instead of using the test factor here, we use the value. And now we could try it again. Let's see what happens here. Okay, we still return null, which is interesting. But of course, after the while loop, we don't return the result list yet. So let's see what we get now. Still an error because we return 2. And the problem is we don't want to have the 2. And even though it would be anyway wrong, right? Because we give 2 inside. And if I look here, we have 2. And this one would be 9. So that would be more than 0. So it should return the number itself. And if this is the case, we have to increase I. So we would jump at least once here, right? So increase value. See where we're jumping. This happens. Okay, this happens actually. So the first one, we are coming twice inside, and then we are returning 2. Okay. Of course, we can't add after we set the I back to 2, we can't add the I, because we lose, of course, the state where we are. So we have to put that up. Let's see where we are now. Okay, we get now at least 3. So, but why do we get 3 times 3? How does it work with that? So if I'm looking back at that one, if we have here a 9 and we would have here a 2, no, a 3, and why would we get here a 3? How should I get that 3? Well, 3 times 3, I get that, but do you know about prime factors with that? So why do we get here 2 times 3? Is it here we get 3 times 2, because 2 times 2 times 2 is 8. Okay, so we have to find something that is exactly the same, so we have to calculate that, or interesting topic, not too easy. So let's see, maybe here we get more information. So after step 1, n must be odd. Now start a loop with from I till 3 to square root of n. Okay. While I divides n. Print I and divide n by I. So while n is divisible by 2, print 2 and divide n by 2. Okay, I think we did that. So while n is divisible by 2, print 2. Is it not like that? 8 divided to 2 equals 4. 4 divided to 2 is 2. 2 divided to 2 is 1. But 1 is not a prime factor as far as I know, and if we look at that here, the test says us that we have 2 times 2 times 2. So if I look again at the prime factors, how they are calculated, we can see up here that we get always the numbers 2, 3, 2, 7, 13 in that case, right? And if I'm reading also down here a little bit, then it seems more that we have to create this prime factor. Interesting. So what do we, so for example, can we get a 9 here, maybe? Maybe then it's more clear what I want to say. 12, 60. So for example, here we have 20, we have 2, 2, 5. So we want the numbers 2, 2, and 5 here. But the question is if there's an algorithm or something that we can use to identify this. So here we have the 8, that would be 2, 2, and 2. So prime factors. How to find prime factors. Whoops. Let's see if we get Google telling us something. Math is fun. Sounds good. 2, 3, 5, 7, 11, 13, and so on. And we have a prime number chart if you need more. So how do we get the factors? Are the numbers you multiply together to get another number, like 2 times 3 is 6. Divide as long as you can't anymore. I thought we do that or not. If we are doing this here, we divide a value to the number as long as until we can't anymore, and then we jump back to the number itself. Don't we do that? So let me check. If I return that to false and we just run that test once more, Let's now see how we come. So we have 2, right? And we want to divide the number with 2. So the value is already 2, so that's why I is not possible to work, right? Because we can just start with 1 and let's see if it's working with that. No, even not. Interesting. So we have to set that to 2 and say here, and I is equal to the value. And now the tests are passing because we divide the number 2 by itself. We understand down here that we can do that because it's 0. We get back 1 in that case, which is the new value, which is smaller than I, and with that the loop is breaking. But in the meantime, we save the value inside. But this is just working once. So with one number, it should be possible. But the problem is, for example, with 9, we get the 9, we divide it, and 9 divided is 3. But it is, by which number it is divided would be interesting, or? Am I completely wrong? No, I think that's good. So let me see if I get that now running. Okay. I think our solution worked already. It was just that I had to add an equal sign here. So because the number 2 could be that the value is the same, and with that we overwritten the while loop all the time. So if I set now all these to false, maybe we are lucky and it's running already. Yeah, that looks good. So here comes a very big factor, so let's see how it turns. Ooh, all right. So guys, well done. Thank you for helping me. That worked better than I expected. So what did we do actually? So we got a result list up here. We have set the value that we want to divide inside of to the new value. We checked if the test factor is 1, because that would be a instant off going, because 1 is not a prime factor. We set the I to 2, which is the first number that we want to check. We go here inside, we check against the value if it's as long as we have I smaller as the value, then we want to divide that number. So that means we want to get the value, in our case the test factor, divided by the number if possible, and if not, we are just getting one number higher. So we check again, is now the new number high enough to be the same as the value, and so on and so forth. And that's actually it. That's nearly everything. And at the end, we returned the result list. Looks pretty clean, I think. So let's see. Do you see any improvements that we can do? So for example, I think we can remove this line here with the comment. I think we don't need that. Also, this comment is, I think, not necessary anymore. Maybe we could add here a comment, but I think it is clear that if the test factor 1 is, that we just return an empty list. Okay, that integer needs to stay here. That is working. That's good. Should we bring in that method, or do you think it is good enough here outside? We could also bring it up here. But I think it looks cleaner if it stays outside, because then everyone understands what happens. Okay, what about the naming? So result list is good. Value, I don't know what value means. So I think it is maybe a helper, or a temp value or a temp factor. Because it is not really a factor, right? It is more the value that we want to check against. So it is more temporary value that we have. So that is the number that we divided it to, right? And I is more the dividable number. All right. So that looks good. And with that, we can say Excersim submit lib and prime factors. Oops. That word. So it is not Excersim, it is Excersim. Okay. Oops. Now I turned it back again. Excersim. Okay, submit. Perfect. So now we have that nice little URL where we can see now our solution. Okay, so now let's have also a look into the community solutions just to check how they solve these issues. So for example, this one has a star. So let's have a look. Ooh. Okay, interesting. So it also has a result list, right? And also checks if the number is 1 or the number is smaller than 1. Yeah, that is true. It could be smaller. I didn't check against that. Then int divisor is 2. Yep, that is what we did. And now number unequal 1 or divisor is unequal the number. Okay, that makes sense. Yeah. Number modulo divisor is 1. Okay, and then at the end we got the information. So it is nearly the same solution that we have, just that we created a method for it to divide all these numbers here. What do we have next? Is there another one that is here? We have another plus. Okay. So this looks quite small compared to ours, right? So he created a normal for loop, and then inside of that for loop he created a while. Number modulo I. Okay, so as long as the number is divisible by I, which is increasing, he makes all of that stuff. Interesting. Cool. Okay, so I would say I'm happy with our solution still. It looks clean. We can read everything. Maybe the names are a bit too long, like divided by number or to divide. Divide by n by number to divide. Maybe this is a bad naming. Divide number. Maybe divide number by would be more than enough. So then we know we divide this number by something. And what do we have else? Temp value is good, I think. The names are pretty good. And we have the factors. Yep. So let's keep it with that. And then I would say complete the solution. We have done that. We have solved now 22 solutions. And that's it for today, I think. We learned something about factors, or at least I learned something about factors, which is always a good thing. Thank you for joining me today, and see you the next time. See ya, guys.